Happy Thursday, everybody, and welcome to day 2 of average rate of change, where the only thing constant in life is change. And that's a lot of what we measure and study with mathematics is how things change, either with a constant rate of change, which is the linear function, or with exponential functions, or with quadratic functions. So this is what we did yesterday. A brief review was we discovered that if a graph of a function is not a straight line, the average rate of change between any 2 points is the slope of the line containing the 2 points called the secant line. And we simply use the slope formula to solve for the slope of the secant line. And the secant line is one of those things that's going to be with you for the rest of your math career. So you learned it and heard it here first in Math 1 at Southern Middle School with Mr. Gillard. So let's go to the first thing that we're going to do today, which is the average rate of change from a table. Okay? Now it says here to find the average rate of change over the interval 1, 5 for the table below. So whenever you see something that's termed an interval and you get two numbers, like you see here 1, 5, those numbers mean your x values. So I'm actually looking for an interval between this x value of 1 and this x value of 5. That is my interval that I'm looking for the average rate of change. So what I use then to solve for the average rate of change is I simply use the slope formula like I did yesterday, but for my y value, I include the other ordered pair that is matched with whatever the x value is in the table. So we know the slope formula is m equals y2 minus y1 divided by x2 minus x1. So in this particular situation, I'm going to let this first set of ordered pairs be x1 and y1, and these will be x2 and y2. So that's going to give me m equals 27 minus 3 divided by 5 minus 1. So 27 minus 3 equals 24. And then 5 minus 1 equals 4. So that means my average rate of change between the interval 1, 5 is 6. That's going to be my average rate of change. Okay, so if we did another example of average rate of change from a table, this one says to find the average rate of change over the interval 1, 3 for the table below. So again, when I look at that, the 1, 3 means I'm using the interval where x is 1 and x is 3. So this is where I'm looking for what is that average rate of change. So then I'm going to, for when I use my slope formula, I'll use these two ordered pairs. So here's my x1 and my y1, and then my x2 and my y2. So again, I say m equals y2 minus y1 divided by x2 minus x1. So that means my slope, or my average rate of change, is going to be 5 minus the negative 3 divided by 3 minus 1. Okay, so two negatives make a positive, so that actually becomes 5 plus 3, which is 8. 3 minus 1 is 2. So again, my average rate of change between these 2 points is going to be 8 divided by 2, which is going to equal 4. So that is my average rate of change between the interval 1, 3. All right, so that's the average rate of change from a table. Now let's look at the average rate of change from a function. So the instructions say to find the average rate of change of the function y equals x squared plus 3x plus 5 over the interval -2, 0. So like we've already said, when we see something like this, which we call interval notation, okay, this is interval notation. We know that both of those are x values, and we're looking for that rate of change between those x values. So what I'm going to do is I'm going to plug both of these x values into the function to get the y value that corresponds to the x value on the coordinate plane. So here we go. If I have y equals x squared, for my first one, that would be y equals a negative 2 squared plus 3 times a negative 2 plus 5. Okay? So y is going to equal negative 2 squared is 4. Then 3 times a negative 2 is going to be negative 6. And then plus 5. So 4 minus 6 is negative 2. Negative 2 plus 5 is a positive 3. So my y value is 3. Therefore, my first order is negative 2, 3. Now, for the 0, we're going to take the same function. So we're going to have y equals 0 squared plus 3 times 0 plus 5. So 0 squared is 0. 3 times 0 is 0. So 0 plus 5 gives me y equals 5. So then my ordered pair here is going to be 0, 5. All right, so the first thing I do is substitute or plug in or input those x values into the function. Now I find the slope between these 2 points. So I'm going to come down here and use my slope formula. And I'm going to say m equals y2 minus y1 over x2 minus x1. All right, so we'll let this over here be my x1 and my y1. And this will be x2 and y2. Okay, so y2 is 5 minus 3. And then x2 is going to be 0 minus a negative 2. So 5 minus 3 is 2. 0 minus a negative 2 becomes 0 plus 2 because 2 negatives make a positive. So 2 divided by 2 equals 1. So my average rate of change for this function over the interval negative 2, 0, that means from negative 2 to 0 on my x-axis, is 1. All right, and our final example. So same thing. It says here to find the average rate of change of the function g of x equals 4x squared plus 3x minus 5 over the interval 3, 7. So that means, again, since I have interval notation, and these brackets mean interval notation, that these are x values, so I'm going to plug each of them into my function. So let's go ahead and do the g of 3 first. So g of 3 equals 4 times 3 squared plus 3 times 3 minus 5. So the g of 3 is going to equal 4 times 9 plus 9 minus 5. So the g of 3 is 36 plus 9 minus 5. So the g of 3 is 40, because 36 plus 9 is 45 minus 5 is 40. So that means my ordered pair here is going to be 340. Now if I come over here and we find the g of 7, which is going to equal 4 times 7 squared plus 3 times 7 minus 5. So the g of 7 is going to be 4 times 49 as 7. Whoa! 7 times 7 is 49 plus 21 minus 5. So 49 times 4 is going to be 196 plus 21 minus 5. gives me a g of 7, which equals 212. So my ordered pair here is going to be 712. Now, same thing. To find my average rate of change, I'm going to take both of these and plug them into my slope formula. So my slope formula is m equals y2 minus y1 over x2 minus x1. All right, so again, we'll let this be x1 and this be y1, x2 and y2. So that gives me 212 minus 40. Well, that wasn't a very good 212. And then 7 minus 3. So 212 minus 40 is 172. And then if I have here 7 minus 3, that gives me 4. So 172 divided by 4 gives me 43. I'll write that over here. So what that means is my average rate of change of the function over the interval 3, 7, meaning we begin with x equals 3 and go to x equals 7, is going to be 43. All right, so what I have for you now is an assignment, which is actually going to be due tomorrow. It's 12 questions. You can have 2 days to do it and turn it in to me on Friday, or you can finish it today. All right, so have a great day. If you have any questions, send me a message through Google Classroom or come up on Google Meet. All right, everyone, have a great Thursday. And this is due Friday, and Friday is going to be a finish work Friday. All right, so have a great day, everybody.